Vocab, center, shape, and spread. This is coming from Chapter 2. Measures of central tendency. So a measure of central tendency is a value that typically represents the center of a whole data set. So typically you're thinking of something like an average or a mean. There's also your median and mode that would also describe the center of your data set. So this section is really about mean, median, and mode. So mean is another word for average. It is the sum of all of your data entries then divided by the number of entries that you had, or divided by your sample size. So with this section, we're going to start adding some notation as far as your variables and the way to write some of this. So sigma notation is when you are summing up all of your data set. So the sigma is this symbol right here. It's a Greek letter. That means to sum. So when we're writing out our population mean, this is our symbol for population mean. It's the Greek letter mu. Kind of looks like a cursive U is the way I typically write it. We add up all of our values in our data set, divide by our sample size. So N is sample size. It's a capital N because it came from a population. And remember, population means all of them. If you had a sample mean, which means you have some missing out of your population set, so you have some, it's the exact same setup. You're adding up all of your numbers, dividing by your sample size, but now sample size is a lowercase n because you're missing some. So it's just a change in notation. The actual math that you were doing is exactly the same between them. And when you have a sample mean, we use X bar. So here we go. Here's our first example. The weights in pounds for a sample of adults before starting a weight loss study are listed. What is the mean weight of the adults? So because it says we have a sample, we would use the symbol X bar to represent the mean. We're going to add up all the numbers and divide by the sample size. So I'm adding them up. 274 plus 235 plus 223 plus 268 plus 290 plus 285 plus 235, and I get a total of 1810. My sample size is how many were there. So 1, 2, 3, 4, 5, 6, 7. I had 7 numbers, so that's my sample size. And then when I divide those, I get 258.57. That would be our sample mean. Now, in case you're wondering, with numbers that have decimals, how many places do we need to go to? Your homework is going to change that every single question. Sometimes it's 1 decimal point, sometimes it's 2, sometimes it's 3. I tend to go for 2 to 4, depending on the problem that we're working on in our notes. But just make sure that you are also correctly rounding. Wherever you do stop, make sure it is correctly rounded. So the next one is our median. It's the value that lives in the middle of the data. But the most important thing is that your data set must be in order. So small to big. Keep in mind with that one, oftentimes we don't give you the data set in order. So that's oftentimes where people get tripped up, is they just take the data set as it is and kind of count down to the middle. You need to make sure very carefully that the data set is in the correct order before you pick out the middle one. Measure the center of an ordered data set by dividing it into 2 equal parts, truly finding that middle value. If there is an odd number, then the median is truly the middle data value. And if there's an even number of entries, then it's going to be the average of the middle two. So here's an example. Find the median of the weight listed in the first example. So same numbers we were dealing with previously, they are not in order. So we first need to put them in order. So looking through the list, it looks like our smallest one is 223. So 223. Then our next one looks to be 235. It looks like we have two of those. Then we've got 268, 274, 285, and then 290. So first step is put them in order. Now to find the middle, what I do when I write this out on paper is I cross off the first and the last one. So this is going to help me kind of get down to the middle. Then I cross off the next one in on both the front half and the back. And then again, and if there's only one number left in the middle, that's your median. If there were two numbers left in the middle, you just find the average of them. So the median is the dead center. So in the previous example, the adult weighing 285 pounds decides not to participate anymore in the study. Now what is going to be our median weight? So let's check the numbers. It looks like they left them in order for us, so we're good. We're in order. So same thing as last one. Mark off the front and back. Mark off one in. And then this is the spot I was talking about. If there's an even number of things and there's two left in the middle, you've got to find the average of them. So you are going to add them and divide by 2 because there are two of them. And we should get 251.5. That is your median. So the last of these three is mode, the data entry that occurs with the greatest frequency. If there is no entry that is repeated, then you can have no mode. That is an option. If two entries occur with the same greatest frequency, then each entry is a mode, and it would be called bimodal. So you could have no mode, you could have one mode, you could have more than one mode. So find the mode of the weights listed in example 1. It helps if you have your data set in order to find the numbers quickly, but what you're looking for is any time a number repeats. So I would go through, if I had a longer list, and I'd underline all the things that repeated, and then whichever one repeated the most, so think of it that way, mode and most, that's the one that's your mode. So in this case, the only number that repeated was 235. That's going to be our mode. At a political debate, a sample of audience members was asked to name the political party to which they belonged. The responses are shown in the table. What is the mode of their responses? So again, mode also means most frequent. So since we have a frequency chart here, the way you're reading this is that Democrats, there were 46 people that selected Democrat. For Republican, there were 34. For Independent, there were 39. And for other, there were 5. So the thing that came up most frequently is the one that has the highest frequency. So we would put our mode as Democrat. It's not the number 46. That's just letting us know how many times it came up. But Democrat would be our mode. So when you put all three of these together, all three of them are trying to describe a typical data set. So by using the mean, it's reliable because it takes into account every single value in your data set. Unfortunately, though, if you have any outliers, things that are far away from the center of the data, it's going to affect the mean the most. So imagine everyone has about the same pay at McDonald's. Everyone's working by the hour, everyone's getting paid $7 an hour. But then you have the manager who's getting paid $15 an hour. If you took the average of all of their salaries together, we would report it as higher than what most of the workers are working, because that one higher outlier is going to pull the rest of the average up. So when we're looking at data sets, it kind of depends on how the spread of the data is as to whether we even use the mean or the median to describe it. So here's a perfect example. The table shows the sample ages of students in a class. Find the mean, median, and mode of all the ages. Are there any outliers? Which measure of central tendency best describes a typical entry of this data set? So the first thing we need to find is the mean, and it does mention this is a sample of ages. So that would be X bar for sample mean. We're going to add them all up and divide by our sample size. So if we add up all the values in this chart, we get 475. And there are 20 students. So if we divide our sum by our sample size, we get 23.75 as our sample mean. For median, there's not a variable that represents median. We just typically write it as MED. Conveniently, everything in our chart is in order. So I could do the same thing I've done previously and slash through them as I go. I'm just going to underline so I don't lose my numbers. I'm underlining one from the front and one from the back as I go, trying to find that middle piece. And I end up with 2 in the middle here. So because I have 2, I need to average them. 21 plus 22, then divide by 2, and I get 21.5 for my median. And the last one is mode. What is the one that comes up most frequently? And you can see it on that top row, 20. There's a lot of 20s in there. Now, are there any outliers? Outliers are things that are far removed from the rest of the numbers. So in this case, we made it pretty obvious just so you could see what an outlier would look like. That would be the number 65. 65 is far away from the rest of the numbers that all happen to be between 20 and 24. Sometimes outliers are very obvious, and sometimes they're a little bit more subtle. We'll talk about later how do we determine that line of what's normal and what's an outlier. But for now, it's obvious. It's 65. So the last question, which measure of central tendency best describes the typical entry? We're trying to figure out which one of mean, median, or mode is a better way of describing this. Because mode is only talking about that first number, 20. It happens to be on the low end. And mode typically is never the one that we talk about, the true central tendency measure. Mean and median are the ones that we typically go back and forth on. And in this case, because we had an outlier, we don't want to use the mean. If you look at the mean, it's kind of on the higher end. It's somewhere in here, which is a little bit higher than where the rest of our data is. The median in this case happens to be a lot closer to the center of what we're doing. So the one that is best is the median. Because we had an outlier. If you didn't have an outlier, we would use the mean. So there's a couple other little ones to add on here. A weighted mean. A weighted mean is the mean of the data set whose entries have varying weights. The weighted mean is given by this formula right here, where W stands for the weight of each one of the entries X. So here's an example. Your grades from last semester are in the table. The grading system assigns points as follows. An A gives you 4, B gives you 3, C gives you 2, D gives you 1, and F gives you 0. Determine your grade point average, or what is also called a weighted mean. So credit hours are your weights. Your final grade is your X's. But we need those in numbers, not letters. So right next to each one, I'm going to change it into a number. So C, they said, was 2. D is 1. A is 4. And B is 3. So again, that formula is the sigma of XW over sigma W. So XW means I need to multiply these across. So I'm just going to come off to the left-hand side here. I'm doing 2 times 3, then 2 times 4, 1 times 1. So I'm multiplying the final grade and the credit hours for each row. And then I'm going to add them up. And when I add them up, I get 40. Sigma W on the bottom means add up all of your weights. So that would be the credit hours column. If I add up all of these, I get the number 16. So 40 divided by 16 means that our weighted average, or GPA, would have been a 2.5. The other type of mean that we want to add is mean of a frequency distribution. That is this formula right here. This is where X and F are the midpoints and frequencies of a class, respectively. And then this might be useful as well, the sum of your frequencies. So we'll talk more about frequency distributions later. So this one's semi-done for you in just a moment. But when you're looking at a frequency distribution, you might have to find the midpoint for each of those ranges first. So lower limit and upper limit, divide it in half. You might need to find the sum of the products of the midpoints and the frequencies. Find the sum of the frequencies, that is your sample size. That also might be given to you. And then you can actually divide. So the sum of each of those midpoints times frequency divided by sample size. So this one's kind of done for you. Midpoints were already found in this first column. Frequencies are given to you, and then they went ahead and did the multiplication for you on the right. So they went ahead and took the midpoint times the frequency and gave you the result. So this one says the frequency distribution shows the out-of-pocket prescription medicine expenses in dollars for 30 U.S. adults in a recent year. Use the frequency distribution to estimate the mean expense. Use the sample mean formula. The mean expense is $285.50. Compare this with the estimated mean. So since they've done most of the work for us, the last thing we're really doing is the final divide. The sum of where they multiplied everything, which is right here at the bottom, divided by our sum of frequency, or our N value. So when we divide this, we get $287.70, which is not that far from the mean expense they were estimating. So the last thing for this section is the shapes of the distribution, whether it is bell-shaped, skewed, uniform. So this first one you're looking at here is called symmetric, or you might have heard it previously called as bell-shaped. And that's coming from the fact that it's got this nice curve to it. We use a lot of bell-shaped curves in this course. So with a curve like this and data set up like this, it means all of those middle values, your mean, your median, and your mode, are very close together in the dead center, which is giving it this nice symmetric shape. And then your data kind of trickles off to both sides. So when you have something that you know is symmetric, we use the mean to describe center. Uniform we don't do very much with, but that would be where all of the data values have equal chance of appearing, or the data set look the same. So you would have like 20 of number 1, 20 of number 2, 20 of number 3. It gives you this nice flat line. And if you don't have a flat line, then it's not uniform. Uniform is truly this flat line. It is symmetric, and it does come up more frequently with probabilities. Now, in addition to symmetric, we also have skewed data a lot. This one is skewed left, and that means that the tail of the data is to the left. So when we say skewed left, it means the bulk of the data is on the right-hand side. Bulk of the data is on the right, and it kind of trickles off to the left as we go down. This would be skewed left, which also means oftentimes that there are outliers on the left-hand side. So that's what's pulling your data down. Now, if you know something is skewed left, or you see a graph that is skewed left, then we would use instead the median for the center, as it's not going to be affected by that outlier the same way the mean would be. So median would be the best measure for the center if you have skewed left. Skewed right is the same way, it's just the mirror image of it. So the bulk of the data is on your left, and then it trickles off to the right. So you have a right tail. And it just gets less and less as we go that direction. In this case, again, if you have something that is skewed, you most likely have an outlier that is pulling that data. So anytime you have outliers, we want to use median to describe your center.